Welcome to Dave's Garage. Wanted to share a little bit about why learning to weld is one of the best skills that you can acquire. One of the reasons is you'll have fancy pieces of furniture and equipment dropped off anonymously for your evaluation and repair. So we're gonna have a look, and holy moly, this is gonna be our project for today. Okay, let's have a look at this leg. A little bit closer evaluation. We've got some rubber on the foot, obviously paint on the outside, and I'm checking my density, my weight of the material. Is it cast aluminum? Is it steel? Is it susceptible to magnets? So probably not aluminum. And so we can identify a little bit more as to how to prep the material and keep it clean and ready to weld. Okay, here we go on prep. The leg, we identified has paint on it and rust on the ends. So we're gonna have a look at the tools that we're gonna use. Wire brush, probably the least aggressive of the tools that I'm going to play with. A flapper disc or a sander disc. A little bit more aggressive and specific to the sides that you're going to be grinding. And a stone. Okay, most aggressive of the grinding methods. So back to the part, I've got paint to remove. Even though I might go back to a more aggressive method, I'm going to start with the wire brush and just clean up the two ends and have a closer look. I'm going to go ahead and fixture my part, and I wanted to give a couple tips or reminders about fixturing product, whether it's on a clamp, on a table. If it's on a vise, you've got jaws, dinosaur teeth, aggressive methods for clamping. And in a product like this, I very well could cause more damage than I want by just simply putting it in my jaws. So I'm going to use fire blanket or a pad rubber mat of some kind, just to give myself just a little bit more distance or room from the jaw teeth and my product. Okay, here we go. Safety protection on wire brush. Obviously, number one, always have your safety glasses on in the shop, period. If you're using a wire brush, these little guys fly off, get stuck all kinds of places. Your body, so good idea, throw on a face shield. Next, throw some gloves. And here we go. I'm gonna go ahead and prep about a ½ inch from the joint. Again, the welding process, we're gonna use GTAW, and I gotta have a clean area, and I also don't want the existing paint to start burning, putting off fumes in my welding area. So here we go. Okay, one side of our cleaning is done, the leg side. And I'm just going to talk real quickly about the cleaning. I don't have any paint within a ½ inch of my joint. The paint that's potentially any closer than that is going to burn. And we're going to get fumes that come off that could be hazardous. So again, pay attention. There's a couple grooves here where the paint comes up just a little bit farther than I would like. And so I might do a little bit more cleaning, get a little bit more of that out of those crevices. Other than that, we're set. Let's look at the bench. All right, got my bench on my table and a couple pointers. This is not too bad, but if the product was bigger, heavier, potentially more dangerous, and it slips off of your table, could hurt you or injure the product even further than what we're already doing. So make sure that you secure your product so it doesn't slip off. I grabbed some wood so I can have some good grip on that cast iron and clamp it down so I can get ready to prep this other side of the joint. Again, we got to pull the paint off of the weld area. There we go. Going to take the paint off of that joint. Watch your eyes. You notice I did a little bit up in this area. Even though I'm not going to weld here, that could start to get hot as well, and I don't want to put that paint fume up in my face while I'm welding. A little bit more in the cracks here. Almost like new. Okay, I want to have a quick look at my joint prior to moving any farther. I want to make sure that the part still has some indexing or some aligning with my grooves, as well as potentially being able to open up the joint, the crack, for access during the welding process. So a quick little fit up reveals it's pretty good as far as cleanliness, but I'm going to use a grinder or a flapper disc and open up those edges just a little bit. Careful not to go too far. You don't want to take off your indexing or part of the original material. You don't want to take all of it off, because then you would lose some of that angle and indexing capability that you have with the crack that's there. Okay, here we go. I'm going to choose the grinding wheel simply because I want very exact precision grind. I don't want to soften my edges more than I have to. The wire brush pretty much did that for me. And I also don't want to put any other contaminants in my weld area. This flapper disc has been used on a lot of different materials, and it's fairly dirty. If I wanted the same cleanliness, I could choose to put a brand new flapper disc on there, but I'm probably still going to pick a stone simply because of the accuracy of my grind. There we go. Okay, I also chose to grind the back side of the joint so that the part that is going to have the larger weld is the part that's hidden. So when I put that part back on there, I have the smallest weld on the visible side, and I'm going to have a larger, more structural weld on the back side. Okay. So process for joining. What options do you have? In my shop, I've got oxy-fuel, GTAW, gas tungsten arc welding, GMAW, gas metal arc welding. I could do some flux core, FCAW. It's probably overdoing it with the size of material that I have. And so we're going to go back down on my welding methods. I also have SMAW. I could do that. Shielded metal arc welding. But I'm going to choose, I'm going to narrow it down to two at this point. Oxy-fuel, where I just burn acetylene and oxygen and manipulate my joint via a flame, or GTAW, gas tungsten arc welding. Or we're going to use a torch, very precise, small location where I'm applying my heat. Now the oxy-fuel would most likely be a little less shocking, no pun intended, to the material. And I might not have as much residual stress if I was to do that. I'm going to chance it. I'm going to go ahead and do GTAW, and let me get my equipment set up and I'll show you where I'm at. So 125 amps. The mode is not SMAW, not stick welding. I've got GTAW HF, high frequency start. My output selector is on DC. Moving over, I've got a slope up at approximately 2 in my range. My pulsar is turned off. It's not going to be used. Arc control set at about 35–40%. The TIG start slope is as low as it can be, meaning when I start, where is it going to start? I like to have an amperage start very, very low. If you want it to start very, very high or have a high start, high amperage start, you can turn that up. My pedal is plugged in, so everything is going to turn on and off, up and down at the pedal. I've got my two filler rods of choice here. I'm going to use ER70S2 and silicon bronze, both 1/16 size, 1/16 diameter. Again, way to know the difference is tint, which is sometimes difficult to make out in a dim shop. But another way is, again, use your magnets. I'm fan of the Knight's Eye Steelies. I've used these for my phones for years, but not gonna interact with the silicon bronze and the steel. Definitely you can see the interaction there, the magnetic fields. So I'm gonna try one of each. Quick review. We've got our product. It's all prepped up, cleaned, edges beveled and prepped for the welding process. Chose our welding process, GTAW. Got those settings taken care of. Got our product positioned and clamped to the table, but a point of interest is the current flowing through the table into your product. Sometimes it's okay, but in this particular case, my product is heavily painted and could cause further damage by throwing the current through the paint potentially. And so what I've done is over here, I've got my work lead from the welding power supply, and I am going to connect that to the table. But I've also got a jumper lead directly from that I'm going to put right next to my work. And I'm going to prep a little bit more paint away so that when I clamp that onto my work, got a good connection. Okay, I've got my supplemental ground set up. Now I'm going to, again, do my dry fit and see if I can hold it there with one hand. And without filler material, I'm going to do an indigenous tack weld. Everything should be set and ready to go. I'm going to verify by pushing the pedal, listening for my gas, and make sure my foot is aligned correctly. And simple little tack. Eyes. Okay, you hear the crack. I did not prep by preheating. Okay, we've got it tacked. Okay, I've chosen the silicon bronze because the material seems fairly prone to cracking, and it's very bubbly or porous. The cast material opens up very quickly. So cooler, lower heat, different filler material is helping out. Okay, you want to be at that welding temperature or heat as little time as possible, and keep that shielding gas on it as long as possible. Basically have a slow cool if possible. Okay, that side's done. Now I'm going to come back onto the other side and fix a couple holes. Okay, quick recap. Got weld area that ended up becoming a little larger than I anticipated. Probably should have cleaned a full 1.5 inches away from the joint. You can see this area, the paint actually started to burn and smoke. So I kind of had to stop and get out of that plume. Same thing on this side. Again, the little charring of the paint, so I did not clear enough of that weld area. And so I'm gonna wire brush that, clean it up just a little bit, and inspect. Not too bad. Pretty good cleanup. There's definitely a lot of other wear spots, some rust spots where paint's flaking off. Part of the problem with doing a high quality repair like this is you might end up spending time fixing other spots, and particularly on cast, be careful about doing that. Again, lots of stress builds up in cast materials. Highly encourage great caution when welding on this type stuff. You can cause it to fracture and crack even more. I did end up being successful, I think, with the silicon bronze, keeping it just a little bit cooler, and I'll blend those welds out just a little bit with a grinding wheel, and then we'll have a final look. Okay, one little note. The brazing material doesn't spark when I'm grinding it, and the product does. And so when I'm trying to blend a weld out like this, as long as I'm blending and don't see sparks, I know I'm within that weld metal. And as soon as I start seeing sparks, I know I'm hitting some of that product. I think that's probably good enough. I'll hit it one more time with a wire brush and call it done. Little note on positioning: when you're trying to do fine-tune work, touch the work, stick your hand on the work, fingers, and you can achieve that standoff distance feel. If you're trying to freehand it, it's going to be a lot more difficult to be very accurate. I've tried to maintain that texture of the cast material. Instead of just having a big lump weld in there, I can actually maintain some of that, and I think we're good. Thanks for watching.